Your kidneys are pretty freaking amazing. One of the things that they do is they filter your blood, and they filter all of your blood, your entire blood volume, up to 40 times a day. This means that your kidneys are going through 150 liters of blood and filtering it. That's pretty impressive. But if you haven't noticed, you don't pee 150 liters. This is because your kidneys are reabsorbing the good things that your body needs more of, and that's leaving behind the waste, which is going to go down the drain. The functional unit of the kidney is the nephron, and you have millions of nephrons in each of your kidneys. We're going to see how they work in this video. As we talk about the nephron, it's important to know that the nephron has several distinct areas. The first one's called the glomerulus. Then you've got the proximal convoluted tubule, the loop of Henle, or nephron loop, the distal convoluted tubule, and the collecting duct. Each collecting duct connects to multiple nephrons. The nephron is responsible for that filtration, reabsorption, and secretion that the kidney does. So let's look closer at the nephron and figure out how it does this. The first part of the nephron is called the glomerulus. This is sort of a knotted capillary that's located inside a structure called the Bowman's capsule. Blood is going to enter this capillary through the afferent arteriole and exit through the efferent arteriole. What happens in that glomerulus is that the pressure from the blood entering that capillary pushes fluid into the Bowman's capsule. From there, that fluid can go through the rest of the nephron. If we look closely at that glomerulus, that capillary has some specializations. It's got little holes in it, which are called fenestrations, and surrounding those fenestrations, it has something called podocytes. Podocytes are cells with finger-like projections, and they're talked about as interdigitating, which means that they go like this. They kind of knit together. And those podocytes cover up some of those holes. What this does is it makes less fluid exit that capillary than ordinarily would. The cool thing about podocytes is we can actually adjust how tight they are together or how loose. So in times where maybe the blood pressure is low and you don't have a lot of pressure pushing fluid through, you're going to make the podocytes further apart to allow more fluid to go through. When you've got high blood pressure or maybe too much fluid that's trying to get through, you clamp off the flow by making those podocytes closer together, and now less fluid will seep through. The area between the podocyte and the fenestrations is called a filtration slit. Basically, because of all of these structures, big things can't get into the urine. So blood cells, large proteins can't get into the urine, but water and electrolytes and smaller molecules can get into the urine. And this is how that glomerulus does filtration. In another video, I'll talk about how hormones adjust that filtration rate, because your body wants to keep it pretty constant, even though as you are sitting and watching Netflix, you're going to have a much lower blood pressure, and that could lead to a lower filtration rate than when you're up and walking around, where your blood pressure is going to go up and now have more fluid trying to get through those capillaries. And we'll talk about how your body adjusts that so that you are always filtering the proper amount of waste. The next part of the nephron is called the proximal convoluted tubule, and this part of the nephron does a lot of absorption. As you might guess, if you were to section through it, guess what it's got inside of it? Microvilli, just like the intestines, to increase surface area and give it more spaces to absorb. While fluids in this proximal convoluted tubule, there are some channels that are pumping material in that didn't make it through the glomerulus so that your body can get rid of a little bit excess waste. That absorption is the reabsorption process we talk about when we talk about the kidney. And that pumping wastes in is what we call secretion. So that's sort of like getting rid of the waste products. The filtration part already occurred in the glomerulus, so we're kind of done with that. From that proximal convoluted tubule, which by the way just means nearby twisty tube, we go down the loop of Henle. The loop of Henle is involved in concentrating urine. What it's going to do is it's going to pull out water and salts, and by the end, what's going to be left is waste. So when we talk about the loop of Henle, this is where it gets kind of complicated. What's going to happen is that loop of Henle is going to go through that renal medulla. The renal medulla has a special adaptation where as we get deeper into it, it gets saltier and saltier and saltier. On the way down, the loop of Henle, the descending loop, is permeable to water. So on the way down, what's going to happen is the fluid inside of that loop is going to try to equilibrate with the area outside. This means that water from the inside is going to go to the outside. So the urine is going to get more concentrated because it's losing water. This gradient is going to get stronger and stronger as we go down that loop of Henle. On our way up, the ascending limb of the loop of Henle, the limb is no longer permeable to water. Now it's permeable to salt. And what this means is that salts are going to start getting pulled out because as it's going upward, it's again going to try to equilibrate with its environment outside of itself. The environment outside of it is getting less and less salty. So the salt is going to try to go out to equilibrate the salt concentrations on both sides. By the end, we have the same concentration that we had going in, but what's in that urine is different. We've reabsorbed the sodium, we've reabsorbed water, and what we're left with is waste. So basically, it's like if I went through your trash and I took out the compost and I took out the recycling, and all you are left with is waste. Even if you still have the same concentration, now we've made it so that more of that garbage is waste. From there, we go through the distal convoluted tubule. That just means distant twisty tube. And this is where there's going to be some fine tuning of the urine concentration. Basically, as we go through this distal convoluted tubule, there's a little bit of absorption going on and a little bit of secretion. When we go down the collecting duct, which is the final segment, we are fine tuning that waste. The distal convoluted tubule and the collecting duct can be hormonally regulated in how much they take in. Why would this be the case? Well, let's say you haven't had a lot of water today, then your body doesn't want to get rid of much. So you're going to release a hormone that's going to cause you to absorb more water. On the opposite end, maybe you've had too much salt, and now we're going to secrete more salt. So we'll talk about that in another video, but you can have a lot of adjustment of urine concentration here. Let's take a closer look at the collecting duct and see what it does. As we go down the collecting duct has channels in it. These are called aquaporins. That sounds like water pour, and that's because that's what it means. These channels will allow water to exit that collecting duct and go into the area around it. Guess what? Collecting duct is going into the medulla as well, so it's going into a saltier area. That's going to make the water want to go out. If we close off those aquaporins, now the water can't exit. If the water can't exit, that means you pee more. Guess what does that? Well, I'll give you a clue. Coffee and alcohol. The two things where if you drink them, you're going to have to visit the bathroom sooner rather than later. It's because you're not reabsorbing that water, and since you're not reabsorbing that water, that means that it's coming out in your urine. This is because those substances block a hormone called antidiuretic hormone, or ADH. And antidiuretic hormone is what inserts those aquaporins into the membrane. In addition, we can also change the salt reabsorption. That salt reabsorption is important because basically we can make it so that we're reabsorbing more salt or less salt. There are times that you're going to want to hold on to more, but if you have too much, your kidneys are going to want to get rid of some. And here we can actually modify that. The goal of this nephron is to get rid of what you don't need and keep what you do. So it is important that it gets modified by hormones to be able to do that. There's one more piece of the nephron that I haven't talked about yet, and this is probably one of the more complicated pieces. It's called the vasorecta. The vasorecta is a series of capillaries that go around the loop of Henle. One of my big issues when I first started studying physiology was that the loop of Henle takes out water and then it takes out salt, but where do those water and salt bits go? Why don't they dilute the medulla? And it turns out that the reason is because you've got this vasorecta. The vasorecta goes in the opposite direction of the loop of Henle. What that means is that as the vasorecta is descending, it's descending where the ascending loop of Henle is, it's going to pick up all that salt that the loop of Henle is letting off because it's going into a saltier environment and it wants to equilibrate. As it ascends, which it does on the side of the descending loop of Henle, it's going to start to pick up water because now it's moving into less and less salty environments and it's going to want to equilibrate there. What this does is I think of it like a vacuum that cleans up all the stuff that comes off the loop of Henle. It turns out that because of the way the blood flows, it actually magnifies the ability of the loop of Henle to concentrate, but we're not going to cover that in this video. Anything that makes it all the way through that nephron and all the way through that collecting duct is going to get emptied into that renal papilla and head on its way to the bladder. So hopefully now you've got a better understanding of how urine is formed. We're going to talk a little bit more in another video about how that formation of urine can be modified by hormones or various physiological disorders such as diabetes.